So today in network analysis we are in a very important topic, time cost analysis. Okay, so we have a project and we have a network for that project. Okay, and we are comparing its time parameter and cost parameters. Okay, so we will get into detail. So as you know, cost is a very big concern for us. Okay, so for example, total cost will be a very big criteria. We want to reduce this cost as much as possible without compromising on quality, okay, and within the time frame. Okay, that is our concern, as we all know, in any project. Okay, so total cost, as we all know, is made up of two costs. Okay, that is general condition. First one is direct cost and indirect cost. Okay, so direct cost is the cost which comes under labor, material and machines. Okay, for a particular building, if you take a building, the wages we pay for the laborers or the working people, that will be coming under direct cost. The raw materials, cost of concrete, steel reinforcement, bricks, M sand, etc. will be coming under direct cost. And the cost of machines also, whatever machines that we are directly employing in the building construction. Okay, so whatever cost that will occur in the project, whatever things will be included in the project at the end, will be coming under cost of those all things will be coming under direct cost. As simple as that. Okay, so obviously everything that does not comes under direct cost will be coming under indirect cost. So we will just write things. Direct cost includes labor, materials, machines, etc. Okay, so wages, receipts, etc. will be coming under direct cost. And for indirect cost, it will be the cost incurring no direct but will be having significant effect, such as rent of the building, administrative cost, security charges, insurance cost, depreciation, etc. Okay, those things will not be coming into those value of that particular cost will not be coming into the building or whatever the product that we are manufacturing by the organization in the project, but these costs are inevitable for any project. You have to set up an office and you have to pay an accountant for this. An accountant will not be contributing significantly to the project, but we need an accountant, right? We need a security. We will be incurring depreciation. We have to pay rent for whatever months we are staying or whatever things we are storing in the storeroom. Okay, so these kinds of things: administration cost, depreciation, rent, insurance, etc. will be coming under indirect cost of a project. Okay, so when comparing with this cost, these two factors of cost and time, how does this vary? Okay, so direct cost, if you may do a graph like this with direct cost in y-axis and time in x-axis, direct cost will vary something like this. Okay, as the time increases, direct cost will be decreasing. Okay, so we extend our time so that we will be more flexible on direct cost. Okay, whereas in case of indirect cost, if we draw the same diagram like indirect cost and time, this will be something like this, quite reverse, because as the time decreases, the rent for the particular room or depreciation or insurance period will always be decreasing, right? As you can imagine, if a particular project is happening for 2 years and we have reduced it for 1 year, rent will be decreased or administrative charges will be decreased. The cost wages we are paying for security items will be decreased, obviously. So in that logic, indirect costs will be decreasing with respect to time. Okay, I think it's clear. And when you take direct cost and indirect cost, you can calculate total cost. Okay, using total cost, if you have this is a particular, suppose this is a netto diagram of this project, 1, 2, 3 and 4. This is a particular diagram, netto diagram of this project, and there will be a particular duration incurring for this, suppose 15 weeks, and that 15 weeks will be the what? The duration of critical path. If this is the critical path, you all know this, I am just repeating myself. This 1, 2, 3, 4 is the critical path. The duration of this critical path will be 15 weeks. Okay, and we call it as normal duration. Normal duration. Note that we have a couple of things coming up. Normal duration is the duration of critical path, the largest path possible, and that will be prioritized, obviously. You know what is critical path, that is normal duration. And sum of all costs, you will have to incur, take all the costs incurred to complete the project, that will be termed as normal cost. Normal cost, two terms, normal duration and normal cost. Okay, so these are the things you need to know basically with time cost relationship. So we are going on to next topic, crashing of a project. Okay, so crashing is a term used to in the process when we reduce the time of our project. Okay, we want to crash the project within a limited time rather than ample time in which we have enough time to arrange everything. Okay, so as you can imagine, crash course are everything that we do it in a least possible time. Okay, so suppose you are taking a single activity like this, 1, 2. Okay, and in that single activity you will be having normal duration of suppose 8 days. Suppose normal duration is 8 days and normal cost is 500 rupees. Say it's an arbitrary figure, 500 rupees is normal cost. Okay, so we will represent like this, normal duration at the top and cost side. Okay, so while crashing there will be a minimum time duration by which it can be, minimum required time duration by which this 1, 2 activity should be completed, should be required to be completed. That is, suppose plastering of a single wall is this activity, we need 8 weeks to, we are planning to do it in 8 weeks. Okay, but we need at least 3 weeks or 3 days to complete with infinity resources. If you are supplying more laborers, we are supplying infinity raw materials and tools, etc. We need at least 3 days. That is crash duration. Okay, so I hope you got the idea. Normal duration 8 in this example is the planned duration by which with the available raw materials and people we can complete within 8 days. So while crash duration is the least possible duration by which we can complete it with infinity resources like labor, raw materials, etc. Okay, so we need to have at least 3, cannot go lesser. Okay, so that is the idea with 3 and 8. Okay, so there will be a cost hike, obviously. Okay, of course there will be cost hike because we are completing an 8-day work within 3 days. So in those 3 days we have to add some things to it. We have to take up some distant labors or some costly raw materials, etc. So that extra cost will be crash cost. Okay, that can be, suppose, say 700. So you will have to endure plus 200 for this particular activity as a whole. Okay, not per day or anything. For if suppose this 1-2 activity was doing normal duration, it would occur only 500 rupees. But if you are crashing it with 3 days, within 3 days, you will have to pay 700. Okay, it's just a requirement, or crashing is just a requirement when there is a particular situation where we need to have least possible amount of time. Okay, we have infinity, we are assuming we are infinity resources, but we need to complete it in the least possible time, the project or as a whole, or an activity as a singular term. Okay, so that is the case when we consider crashing. It is not an ideal situation. In every time we need to compress the time. Okay, so this is the expression. I hope you understand. And these 4 terms, normal duration, normal cost, crash duration, crash cost, can be attributed to total project and single activities. So we have just told about in the terms of a singular activity, can also be told as total cost, total project also, in terms of total project also. Okay, so we are just considering, so in these will be direct cost. Okay, we are not talking about indirect cost right now. Okay, so suppose we are drawing a graph that we have just drawn some time ago. Direct cost. Okay, so as we know, direct cost varies with time, like this. Okay, and normal duration will be somewhere like here, 8 days. Normal duration, right? So normal duration, normal cost will be the corresponding y ordinate, right? That is normal cost. Okay, so what will be the crash duration? 3 days will be somewhere like here. Crash duration, and obviously the 700 will be direct cost, highest direct cost, that is crash cost. Okay, so we have marked all these 4 parameters into a single diagram. Okay. And as we all know, what will be the slope of this curve? The slope of this curve will be delta y by delta x, obviously mathematics. That will be crash cost delta y, that is bigger ordinary, crash cost minus normal cost divided by bigger duration, that is normal duration minus crash duration. Okay, so this equation or this parameter we just calculated is known as cost slope, and this equation is important. Okay, so cost slope is the ratio between crash cost minus normal cost and normal duration minus crash duration. Okay, so just subtract the smallest one from the biggest one. The biggest one will be crash cost in terms of cost and normal duration in case of time. Okay, so I hope you got the idea. So we have these terms, 4 terms, and cost slope. Okay, and now we move on to cost optimization. Cost optimization is, as the name indicates, is finding out the minimum total cost possible for any project. Okay, as we know, if this, I'm just drawing a bigger one, time and cost, not direct cost. Okay, so as we know, if I'm drawing a line with respect to direct cost, I know I will be getting a line like this. Okay, this will be direct cost. It will be decreasing with increasing time. But in case of indirect cost, this will be something like this. It will be decreasing with decreasing time, quite opposite to direct cost. Okay, so we take, as we know, total cost is something which is obtained by adding direct and indirect cost. You know, you can just add up these values, so you will be getting something like this. Okay, as we, it's evident from the figure, it may not be accurate, the trend may not be accurate in exact factors, but you will be getting an optimum value. Okay, and this portion where you will be having the minimum total cost, not direct cost, not indirect cost, the minimum total cost is where you will get optimum duration, not crash duration, optimum duration of the project. Okay, in which you have optimum cost. So optimum duration is the duration of the project in which the project can be completed in the minimum optimum or minimum most cost. Okay, so that is a plan of important. If you have direct cost flow and indirect cost flow, you can find the optimum cost and optimum duration by which it can be completed. Obviously that is beneficial for us. For suppose we are in charge of doing this project, you obviously will be choosing with optimum cost value because that is the least costing for us. Okay, so in either way it will be increasing. If whether the duration is increasing or decreasing, cost will be increasing, right? So obviously we will be going for this. Okay, so right now we will be concentrating on cost optimization and how we will be doing it. Okay, so we will just do it by an example. Okay. So this is the question. You have 4 activities. This is the diagram. You will be given the diagram. Sometimes you may not give the diagram. You may not be given. You will have to draw by yourself. It will not be a big problem. So it will be simpler as possible. So we have 4 activities: normal times, crash times, normal cost, and crash cost. Okay. So from this you will have to find optimum duration and optimum cost of this project. Okay, so as we in the last minutes we drew a graph, so you need to obtain the least possible cost and corresponding duration. Okay, so these costs are direct cost. indirect cost is rupees 250 per day, okay, for any unit per day, okay. So up to this, that what is the duration from start to end, multiply with 250, you will get the indirect cost, and add total direct cost and total indirect cost, you will get total cost, okay, obviously. So step one is calculate cost slope of all activities, okay. Cost slope, you know the equation, cost slope is equal to crash cost minus normal cost divided by normal duration minus crash duration, okay. So for each activity you need to have cost slope, so we will write as a separate column in here, cost slope. So for first I will just the first one, for 10-20 activity, cost slope is equal to CC, that is 600 minus 400 divided by normal duration minus crash duration, okay. So that is 200, so that is 200 is a cost slope. And let me make you understand the concept of this cost slope. Cost slope means for every time we reduce this activity 10-20, this activity 10-20 activity, by one day you will be increasing or adding 200 rupees to the cost, okay. I'll say one more time. Every day, right now it is 4 days duration and it can be reduced to 3 days, okay. So when we reduce one day, it can only be reduced to 1 day, okay. So when we reduce 1 day from 4 to 3, it will take, you will have to pay 200 more, that is cost slope, okay. And next one, 150, 90, 250, okay. So I'll just write these details into the network analysis network. 20, 30 is 5 in bracket 2. 20, 40 is 7 in bracket 5, and 30, 40 is 4 in bracket 2, okay. So if you take 30-40 activity, you can reduce this 4-day duration activity into 2-day duration. You can take out 2 days. For each day you will have to pay 250 rupees more, okay. So for if you are making this 4-day activity into 3-day activity, it's possible. Then you have to pay 250 rupees direct cost, and if we are again making it 2 days, crashing again and making it 2 days, you will again have to put out 200 rupees again, okay. So each time when we reduce the time of that particular activity with a particular day or that particular unit, that cost slope will be the additional direct cost, increase in additional direct cost, okay. So that is the concept. So you have crash cost slope. Step 2, calculate the total cost and duration of project, okay. Total cost is how do we calculate total cost? Just add normal cost, whether or not the activities, some activities are not critical or not, doesn't affect the fact that you have to do these activities. You have to carry out all these activities, all these set of activities. So just add normal cost, not crash cost, just add normal cost. So 400 plus 300 plus 360 plus 500, that is 1560 rupees. Okay, so then calculate total duration. What will be the total duration? Okay, so for that we will draw another table with the help of network. Okay, so you have parts. We can take two parts which are 10, 20, 40 is one part, and using that you can take how much? 4 is the normal duration, 4, 7 is the next duration, normal duration, right? So normal duration Tn is 11. Okay, and for there is another path 10, 20, 30, 40. That is 10, 20, 30, 40. That is 4 plus 5 plus 4. That is 30. Right. Okay. So which one is the critical path? The greater one, right? This is critical path. For the time being, it will be changing. You will know shortly. For the time being, as this is having the largest duration, 10, 20, 30, 40. This 10, 20, 30, 40. This is the critical path. Okay. And we have calculated normal durations. And now we will calculate crash durations. Okay. What can be the minimum most possible duration of the project? Okay, so that is for 10, 20, 40, 10, 20, 40, what is the crash course? 3 plus 5, that is 8. For the other one, 10, 20, 30, 40, that is 3 plus 2 plus 2, that is 7. Okay, so the normal duration, the total duration, initial total duration will be 13 days, right? And what will be the possible, please pay attention, what will be the possible minimum duration of this project? The possible minimum duration will be 8 days. Right. What are these values inside the bracket? These are the minimum requirement of each activity. Right. 10, 20 activity need to have at least 3 to complete. Even if you are crashing to its maximum extent, it need 3 days. For 20, 40 it need at least 5 days. For 20, 30 we need 2 days, and 30, 40 2 days. So we are just taking the path and we have found out 8 days for 10, 20, 40 path and 7 days for the other one. Okay. So even if we are supposed to take this path into 7 days, suppose we are taking this critical path, the time being critical path into 7 days, even then this will be the greater one. Then this path will become the new critical path and this will be the new duration, right? So 13 days will be the normal duration and 8 days will be the maximum of these two, will be the least possible duration of project. I hope the idea is clear. 13 days is the we are not talked about this earlier. This 8 days is important. Why do we pick 8 days? Because we need to take the bigger one, because we cannot take the least one, because the bigger one will be always there. We cannot reduce this path less than 8 days. That is the meaning. And we cannot reduce this path less than 7 days. Even if we reduce this path into 7 days, this path will be having 8 days. So this path will be becoming critical path, and that will be the total duration. Okay. So right now normal duration is 13, and from 13 it can be reduced to 8 days. So I just simplified that table into here. Part 1 and part 2, 11 and 13, 8 and 7. So you know you need to have 13 to 8. You can reduce the total duration of this project. Right now it is 13. You can reduce till 8. Okay. So I hope that's clear. Okay. And just leave some space aside. It will be useful. So second step was calculation of total cost and total duration. Right now duration is 13 days, and total cost, what is the total cost? Corresponding to 13 days, total cost is, or we will write here, duration 13 days, total cost. What is the total cost? Direct cost plus indirect cost. Right, we discussed earlier. What is direct cost? Direct cost is 1560. Sum of all these two things are direct cost. Okay. So 1560 is the direct cost. What will be the indirect cost? 250 per day. There are 13 days. Right. So 13 into 250. Okay. So you will get 4810 rupees. So that is the current total cost. So we will just write it corresponding to 13 days. 4810. Okay. This total cost corresponding to 13 days. Now we will reduce these costs with each reduction of 1 day. We will crash 1 day at a time. That's what we are going to do. And that is step 3. So from 13 days duration, we will reduce it into 12, 11, 10, 9, 8. 8 is the minimum possible. So we will stop at 8. Okay. So what you are going to do is then compare, take all the total costs corresponding to all these values, 12, 11, 10, 9, 8. You will calculate total cost corresponding to all these durations, and we will take the minimum of these. Suppose 11th day corresponding to the total cost is minimum. You will select this one as the optimum cost. If 10th one is minimum, you will take 10th one. Okay, that is what we are going to do. So right now, third step is crash 1 day at a time. Okay, so that is a bit tricky. We will just get into it. So we have got these values in here. Okay. So step 3, crashing. Right now we are reducing 13 duration into 12. Okay. So when crashing, you will be having 3 cases. This is the most tricky part. Please pay attention. 3 cases you can have. First one is case 1. Case 1. one critical path, single critical path. If there is only one critical path, then we know what to do. Take the activity corresponding to minimum cost slope in that path. Okay, so we will take this example. Right now we want to reduce 13 to 12. The total duration is 30 days. We want to make it into 12. Okay, so right now the critical path is this path, 10, 20, 30, 40. Right, 10, 20, 30, 40, this path. From these three activities in which critical path is going on, which are 10, 20, 20, 30, not third one, 30, 40. So we can compare 1, 2, 3. Among these three, take minimum, take the activity or crash the activity with minimum cost slope. As simple as that. Because as we know, the logic is clear. This is the additional cost you will have to pay for 1 day reduction, crashing. So we have the option. This is the critical path. These are the two available options, and you have to reduce 1 day from any of these. So right now you can reduce the one with 200 or 150 or 250. So obviously you will take the least cost incurring option, that is 20-30, the path of 20-30, this one. Okay, so we'll do that in a short while. I'll just complete explaining the case 2 and case 3. Okay, so case 2 is, suppose there are two critical paths, more than one critical path, greater than one critical path. Then what will do? Okay, so in this example itself, it's now 12, right? Then we'll get it into 11. Then what will happen? There will be two critical paths. They will be equal to 10, 20, 40 path. So there will be two critical paths. Then what will do? Then we will crash the common activity. Is there any common activity in this critical paths? The first path is 10, 20, 40. Second one is 10, 20, 30, 40. That is, there is common activity 10, 20. So if there is two critical paths possible, just crash the common activity. Okay, that's simpler. You can just crash the one single activity and it's over. And suppose the case 3 is, there is more than one critical path without common activity. There is no common activity, but there are two critical paths. Okay, then what we will do is, we will take each critical paths and take two activities. We will crash two activities because there will be two paths, right? If suppose this was the issue, 1, 10, 20, 40 and 10, 20, 30, 40, we will take one from this critical path and the other from another critical path. We will reduce, or we will crash 1 day of both activities, so that we will reduce the total project duration to 1 day. Okay, we will reduce 1 day of total duration, but we need to crash two activities because it is like a parallel thing. Either way you are reaching 40, if you are crashing 2040 and 2030, in effect you are reducing only 1 day. Okay, so that's the case if there are more than one critical path with the common activity. We will crash, then again we will select least cost slope, least cost slope activity from each critical paths. Okay, we won't just take any one, we will consider, we will compare between these two and take the minimum of critical path. Select the one with minimum cost slope. Okay, so that is the case with step 3. Okay, if there is only one critical path, crash the item with minimum cost. That's simple. If there is more than one critical path, crash the common activity. If there is more than one critical path without common activity, crash each critical paths at least one activity with least cost slope. Okay, I hope that's clear. So moving on with our example. Okay, so now we have decided what to do. We will just take 2030. This is the critical path, and in this critical path 2030 is the one with minimum cost slope. So we will reduce this, we will cut this like this and rewrite it as 4 2. Okay, the inside the bracket will be always same because it cannot be changed. The duration, total duration, we are reducing from 5 to 4. We are taking 1 day out, right? Okay, so it became 12. Okay, so these tables should be always present. Okay, so we have taken out 1 day out of it, and we have taken out 1 day from this path. Okay, I hope it's clear, right? And now you want to calculate total cost corresponding to 12-day duration. How do we calculate that? Direct cost is equal to, what was the direct cost for 13 days? 1560. So is there any change for direct cost? Yes, you will have to pay 150 rupees more, right? So direct cost is 150 plus 1560, that is 1710. An indirect cost, as you can imagine, it's 250 per day. That is, duration is 12 into 250. That's equal to 3000 rupees. Okay, so total cost is equal to, adding these two, 4710. So corresponding to 12 days, you will have to pay this much. The cost is reducing, right? So the graph is going down. So that was with the crashing of 1 day. Now we are continuing the crashing process. What will be the end of it? It will end with 8 days. That is the extent. We will stop with 8, then compare. Okay, so now we are taking, now it is 12, right? The critical path is 12. Now we will make it 11. How? We will again compare the cost slopes of these three activities, because when it was, right now it is 12, this is the critical path. So then again we will compare. Obviously again we can reduce, take 1 day from in here, that is 3 in the brackets 2. Okay, so and again direct cost is equal to, what was the direct cost? $1710. Okay, do not make a mistake. Direct cost should be taken not from here. Direct cost should be taken from the previous day, previous next bigger day, the current situation. So in this case, the cost, direct cost was 1710. Okay, so you will deal with that plus how much you reduce 1 day. So as cost slope is 150, you will take 150. Okay, so that is 0, 6, 8, 1860. Indirect cost how many days? 11 days. 11 into 250, that is 2750. So to get the total cost, you will just add this, you will get 4610. So that's done. Note this value 1860. You need to have it for the next calculation, right? Okay, so I'll just write here 1860. Now this is the second case, right? We have two paths with equal duration, that is you have two critical paths, more than one critical path, and from these two critical paths, what was the option? Reduce or crash the common activity. What one is the common activity? 10, 20, 40 and 10, 20, 30, 40. The only common activity is 10, 20. Suppose if there were more than one common activity, you will take out the minimum cost of common activity. Okay, that's simple. So 10, 20 is the common activity. So you will just reduce it 3, 3. So that means you cannot further reduce it. Okay, so 10, 10. So we have reduced 10, 20 activity into 3 days. Okay, so direct cost 1860 plus what? 200. That's equal to 2060. Indirect cost is right now 10 into 250, that is 2500. Total cost is 0653. 4, that is for 10 days. Okay. Next case, so 2060, that is a new direct cost. So right now you are having common activities, common critical paths, two critical paths, but you cannot touch on this activity because it has reached its maximum or minimum duration, 3 days. Okay, so it cannot go below 3. So that's forbidden. Then you will take this cycle. Okay. It's the third case. You have greater than one critical path. Then you will take the two activities. That is, one from one path and the other from another critical path, and take each days from each activity. 1 day in effect. Okay. So obviously, for taking out 9, okay, we will have to reduce this activity 6, 5, and comparing with these two, we will have to settle with 20, 30, this one, and 30, 40, this one. Obviously, we have one more days left here. So, last one. Okay. So, I hope it's clear. This had hit its maximum. So we will take 1 day each from this activity and 1 day from this cycle. So we will compare the cost flow from these two activities, and we selected 2030 as it was minimum. Okay. So that was that, and direct cost was 2060 plus how much? For 2040 it was 90, and we crashed one more 2030. 2030 it was 150. That is equal to 2300, and indirect cost, it is duration is 9 into 250, that is equal to 2250. The total cost is 4550. For duration 9, 4550. Okay. Last one 2300 we will be keeping here. Okay, so last one we have reached this value 8. Okay, so we have hit its maximum. So there is only two options left, 5, 5 and 3, 2. Okay, so as you can see, it is one more day left for 3T40. That's why we have 7 in here, right? Okay, so again we have taken the same steps as the previous one. So 2300 plus 90 plus 150 of, sorry, not 150, we crash, instead of 2030 we crash 3040, so 90 plus 250, 3040, 250. Okay, so you will get 2640, and indirect cost is 8 into 250 is equal to 2000. The total is 4640. So the last one 4640. So this is the final list. Okay, so we have calculated the corresponding total cost with respect to durations from 13 to 8. Okay, so now if you want, you can draw a graph. In the question, if you are asked, you are supposed to draw a graph, you can just take this as x coordinate and this values are y coordinate. Okay, so right now we don't need to do that. You will just take the minimum of total cost. The minimum of total cost is this value 4550. Okay, so that's it. The optimum cost of the project is equal to 4550, and hence optimum duration of the project is 9 days. That is the answer. Okay, So it was the first one, that's why we went given too much time. If you do 2 more problems, you will get used to it. With these diagrams and about this particular table, you can just go on calculating the values like this. Okay, you just need to select. Okay, so there is no need to confuse or anything. It's very easy if you just understand the order. Okay, thanks.